Hi everyone, today I'd like to talk to you about neutralization. And as you may remember, we are talking about neutralization when the differences of underlined segments are erased or neutralized on the surface. And it usually happens when we apply a certain phonological rule, or maybe a few of them. So how do we do neutralization problems? So the first thing to do, it's kind of obvious, but you still have to do it, so you have to study the data. So let's imagine that this is the language we have. What do we have here? We have ucha, a dog, icha, the dog, uka, a mouse, icha, the mouse. So the second thing to do will be to list all possible alternates. And you should always go for the easiest stuff and find the longest strings of shared segments. Like here, for example, if you compare everything, you will see that the only possible thing to go for is cha, because this is the longest string of shared segments. And cha stands for dog in our case. In C and D, we see some alternation. We have ka and cha. And at the beginning of all words, the segments alternate. So we make an assumption that cha is dog. Now, subtracting cha from the word ucha, we get e. To confirm our assumption, we can also have a look at the word a mouse, and we can also see that it begins with u. So u means e. Then we can also subtract cha from the word icha to get the. And again, let's compare it to something else that contains the in it. Looking at D, we can also see that the mouse begins with e. And again, it confirms our assumption, so we write that e is the. Subtracting u and e from C and D, we actually get two possible alternates of the morpheme mouse. So these are all alternates that we have found so far. Cha, dog, cha or ka, mouse, u, e, the. The next thing to do would be to choose a rule. So we can see that we have cha to mean dog and ka or cha to mean mouse. So this is basically where the alternation occurs. Now we have to find out which rule is in effect so that we could see on the surface ka and cha for mouse. So one of the possible rules would be chu becomes ku after u. But if you look at our data, we see that it contradicts what we see, right? Because in A, we were supposed to have uka if that rule was applied, but we have ucha, so that rule doesn't work. We can also assume that another possible rule is ku becomes chu after e. And if we look at all our data, we will see that it works because all our forms on the surface stay the same. And now we can choose the underlying representation for the morpheme mouse. It should be ka. So in the person's brain, this is what is stored. Cha, dog, ka, mouse, u, e, the. In the last step, we have to fill in the table. The table usually has a few rows. The underlying representation, one rule or more rules, it depends on the situation. Then you have to list all surface representation forms, and of course a gloss. So we'll begin with the first row, the underlying representation one. And actually now you have all the data you need to fill it in. Each word consists of morphemes, and our first word is a dog, and for that you need u and cha, and you will have ucha. To get that dog, you need e and cha, and you'll get icha. To get a mouse, take u and ka, and you'll get uka. And to form the mouse, you need e and ka, and you get ika. So we are done with our underlying representation, and we have ucha for dog, icha for the dog, uka for a mouse, and ika for the mouse. The surface representation row is the easiest one because you have been given all this data at the start. So now we have 3 rows complete. the underline representation one, the surface representation one, and the gloss. So if you remember, our rule was K becomes Ch after E. All we have to do now is to compare the underline representation with the surface representation, and if we see some differences, it means that the rule has been applied. So let's do it. Comparing ucha with ucha, we observe no effect of the rule, so that means that the rule has been applied vacuously. And we put a dash. Now let's compare the dog. Icha doesn't differ from icha, so again the rule has been applied vacuously. Comparing uka to uka, we observe no difference again, so that means that the rule has been applied vacuously. So it had no effect. Now let's compare the last word. Ika versus icha. Wow, we see some change here, right? So that means that in this time, our rule has been applied non-vacuously. In other words, it had some effect. It led to this change from K to Ch. Why did K change into Ch? Because there was E before it. And that's what we write in this row. We have to write icha. We have to write what effect the application of that rule had on the word, on the underlined representation. So our table is done. It's been filled in. And that's it.